Hi everyone, here are your formal notes on special right triangles. Okay, so you looked at 45, 45, 90-degree triangles in class today, and you looked at 30, 60, 90. So let's take a closer look at 45, 45, 90 triangles. So let's start with a square. Remember that a square has all of the properties that a parallelogram has, a rhombus has, and a rectangle. So if you drew a diagonal in a square, think about what those properties will do to the angles, to the two triangles that you get. Okay, so you have a 90-degree angle, and then the diagonal, since it's a square and a rhombus, it's going to bisect the opposite angles. Okay, so when you draw one diagonal, you get two 45, 45, 90 triangles. Okay, you guys today in class use Pythagorean theorem to figure out the relationship amongst the sides of a 45, 45, 90 triangle. Okay, so your official theorem for 45, 45, 90 triangles, in a 45, 45, 90 triangle, the legs are congruent and the hypotenuse is the square root of 2 times the length of a leg. Okay, so you have two legs, they are always congruent, and then remember the hypotenuse is across from the right angle, and your hypotenuse is always your leg times the square root of 2. Okay, so let's do an example. So we have a 45, 45, 90 triangle. I know it's a right triangle. I know by the way the legs and the angles are labeled that these two angles are 45 degrees. And I know each of my legs are 9 square root of 2. Okay, so x is my hypotenuse. Using my theorem, knowing that my hypotenuse is my leg times the square root of 2, x is going to be 9 square root of 2 times the square root of 2, okay, because the leg was 9 square root of 2. So when I multiply all of that out, remember the square root of 2 times the square root of 2 cancels the square root, so I really get 9 times 2, so my hypotenuse is 18. If I look at the next example, okay, now I'm going to work backwards. I know that my hypotenuse is 4. I need to figure out what the legs are. Okay, so using my formula, hypotenuse equals your leg times the square root of 2. Plug in what you know. 4 equals my leg times the square root of 2. Now, if I want to get rid of the square root of 2, I'm going to divide on both sides because the leg is like your variable. Okay, and you get 4 divided by the square root of 2 equals your leg. Now remember, we don't want to have square roots in our denominator, so we're going to rationalize that. Okay, so when we do that, we're going to multiply the top and bottom by the denominator. Okay, and then I can simplify that to 2 square root of 2. So each leg is 2 square root of 2. Now if I want to check this, I know that my hypotenuse equals my leg times the square root of 2. So I know my hypotenuse is 4. My leg that I discovered was 2 square root of 2. If I multiply all of that out, square root of 2 times the square root of 2 is 2. 2 times 2 is 4. 4 equals 4, and we're good to go. All right, now let's look at a 30, 60, 90 triangle. Okay, so if I have an equilateral triangle, so remember all three sides are congruent, all three angles are congruent, and I draw an altitude in that triangle, that altitude is going to be a bisector of the base of this triangle, and it's going to form right angles. Okay, so I have two smaller right triangles when I draw that altitude. Now, if each side is 2x, I just gave it an arbitrary value, this altitude is going to split the base into x and x, so the whole thing adds up to 2x. Okay, if I use Pythagorean theorem to figure out what the altitude is. Okay, so if I use Pythagorean theorem, let's call x a, actually, since altitude is a, let's call the altitude a. We'll call x b, and then your hypotenuse is c. So we're going to do a squared plus b squared equals c squared. So a for altitude, b squared is x squared, equals 2x squared. Okay, so I get a squared plus x squared equals 4x squared. Okay, a squared is going to equal 3x squared. I subtract x squared from both sides. And then I need to take the square root on both sides. Okay, now 3x squared is the same as 3 times x squared. So I can rewrite square root of 3x squared as the square root of 3 times the square root of x squared. Okay, square root of 3 can't be simplified anymore. Okay, but when I take the square root of x squared, they cancel out and I'm left with just an x. So the proper way to write this is to put the x in front of the radical. So my altitude is x times the square root of 3. And if you notice, it's this smaller side here times the square root of 3. And that's going to lead us to the theorem we have about the sides of a 30, 60, 90 triangle. So your 30, 60, 90 triangle theorem says in a 30, 60, 90 triangle, the hypotenuse h is 2 times the length of the shorter leg. The longer leg is square root of 3 times the length of the short leg. Okay, so if you look at the three angles in a triangle, and you remember that we said the shortest side is across from the smallest angle, the largest angle is across from the largest side. Okay, the smallest angle is 30 degrees. So if you go across your triangle, the side opposite that is always your short leg. Okay, your hypotenuse is always across from the 90-degree angle, and it is always 2 times your short leg. And then your long leg is always across from the 60-degree angle, and it is your short leg times the square root of 3. Okay, this is a fact that you have to remember about a 30, 60, 90 triangle. Okay, so let's do an example. If I look at this triangle, I need to find x and y. I know one angle is 90, the other is 60, so you need to start recognizing that right away the third angle is going to be 30, and you're working with a special right triangle. Okay, once you know what the angles are, you need to label the sides, hypotenuse, long leg, and short leg. Okay, so the hypotenuse is always across from your right angle, short leg is across from 30, and your long leg. Okay, using my theorem, I know that my short leg is half the length of the hypotenuse, or you can say your hypotenuse is 2 times your short leg. So 10 is 2 times my short leg. Divide both sides by 2. That means your short leg is 5. So x is 5. Okay, that's easy enough. Now for your long leg is your short leg times the square root of 3. So we just discovered that the short leg was 5 times the square root of 3. So that means in this problem, y is 5 square root of 3. No decimals, just working with radicals in simplest radical form. Okay, and last example for the day. Suppose we have a zip line anchored in one corner of a course shaped like a rectangular prism. The other end is anchored to the opposite corner as shown. So if the zip line makes a 60-degree angle with post AF, so here's AF and here's our 60-degree angle, find the length of the zip line. Okay, so the zip line okay, so if you look at the triangle we have here, okay, we have a right angle here, we have a 60 degree, so that means this is a 30 degree, and we're working with a 30, 60, 90 triangle. Okay, since we're looking for the length of the zip line, that's the hypotenuse. Okay, we know this side is 25 feet, and it's across from the 30-degree angle, so that is my short leg. Okay, and we know using our 30, 60, 90 triangle theorem that the hypotenuse is 2 times your short leg. So my hypotenuse should be 50 feet. Okay, so I can say the length of the zip line is 50 feet. All right, use these notes and work through your homework examples, and we will go over the homework in class tomorrow. Have a good afternoon, everybody.